I'm here to talk about weather stations. I'll admit it's not the most sexy topic, but I'll try to make it a fun presentation anyway. So about me, my name is Paul. I'm a system administrator, been so for 25 years, mostly Linux and open source. In my free time, I like to cook, and I write silly, useful little software like open up the garbage collection application that they closed down. I'm publishing this in a iCal format on some server and all that kind of stuff. Um, but yeah, weather stations. So let's complain about the weather. I'm try and use a weather station as an example of how you can use hardware and leverage that data and send it to a home server or hardware setup. But you can basically use anything for this, not just a weather station. I mean, um, there's thermostats and other smart devices like doorbells and what else not that people just send into the cloud, not knowing where their data ends up, privacy concerns, security concerns, all that kind of stuff. So I've built this small setup at home, and I'll demonstrate how I did this today. It's Software Freedom Day. What that means to me is like open source software, and how to use it. I use open source software every day in my day job. I assume everybody here is quite technical, so the next couple of slides are not that interesting. But like I picked curl as a great example. Are there people here who do not know what curl is? Everybody knows what curl is? Yeah, okay. So curl is like, I think, one of the most used open source components in the world. The data here on this slide is from 2018, so it's probably outdated already, but just to give you an idea, curl runs like everywhere, on every smartphone, in Windows, television sets, even in cars. And I think that demonstrates the power of open source. It's omnipresent. People usually don't even know they're running curl or their device in their pocket is running curl. So yeah, small context, open source, Software Freedom Day. And in this quick small presentation, I try to use as much as open source components as I can. Not everything, unfortunately, but I'll get to that in a minute. So yeah, the topic of this Software Freedom Day was like owning your own cloud. When I think of cloud, I think of the big three players: AWS, Google, and Azure. And these three are so omnipresent everywhere that people don't even know that they are using them. Like everybody uses Netflix or Prime Video. It's Me authentication service runs on Azure. Google, Payconic, all that kind of stuff. So I want to go against the default omnipresence of these big cloud companies, because people are so unaware that they are using these services. So this brings us to the Internet of Things and my little weather station. You have smart devices everywhere. Doorbells, internet-connected fridges, weather stations. In my example, smart heating systems, ventilation systems at home. Everything's connected. I have an issue with that because the letter S in IoT stands for security. I mean, it's not secure at all. You just connect something to your Wi-Fi, it starts beaming data. People are unaware of what they are sending. These little devices don't get updated, they don't get the latest security patches. It's just a big mess, in my opinion. So yeah, an example of a internet-connected smart lock that got hacked with some small Python script. It just opens the door. And so the point I'm trying to make is when you buy these little pieces of hardware that can create value and make you do cool stuff, just be aware of what you're buying, and can you leverage the data? Can you control the data stream? Do you know where your data is ending up? Yeah. Asseyez-vous. So yeah, I just want to make a point, like when you buy stuff, make sure that you can control the data stream and see what you can do with it. So the weather station I'm using started off as a little experiment because weather applications are everywhere. You don't need your own weather station to know what type of weather it is or what the temperature is. There's tons of applications and weather websites. But so I'm leaning into the home automation thing. And of course you have big players like Apple and Google with Home Assistant, and I don't know what the Google thing is called, but you can buy a ton of small devices and they just automatically connect to Apple or Google, and you have no idea what data you're sending over the internet, what data is being recorded. So enter Home Assistant. Home Assistant is an open source home automation software suite with tons and tons of extensions and libraries. And so my little weather station at home has a plugin for it. Somebody wrote a plugin, and you can capture the data stream from the weather station and send it into Home Assistant, and then build some automation based on that. I'm not there yet. I'm just capturing the data stream. I'm not doing anything useful with it just now. But my plan is to install some smart thermostat system, open source, using the OpenTerm protocol, and then based on my metrics of the outside temperature, inside temperature, the difference, and so on, steer my central heating system at home, and make it a little bit more intelligent and remotely controlled than what I have now. So obviously you need a home server if you want to capture that data stream and do something with it. You could send it to the cloud, but I opted for a physical hardware in my home because it plays nice when you have your Home Assistant system running inside your home network. It makes the connection with the device in your garden a bit easier than having your server up in the cloud. So as an overview of my little home setup, top left corner is my physical weather station that's in my garden, and then there's a radio connection from this hardware device to a small computer that's inside my home, and that device is connected to my home network, and this device allows me to control my data streams. So the obvious thing to do is to simply send this data to some commercial online weather service or an open free weather service like Weather Underground. I chose to use EcoWit because that's what this small appliance supports, and I have some slides of that data. But apart from that, there's also the WOWBE service. Like that's the weather observation website. It's something that got started in the UK, but the Belgian KMI, I don't know what the English abbreviation for that is, but the Belgian Weather or Meteorological Institute has the Belgian side of it, and you can register your device on there and send your data stream there, and you will get registered on their website, and then they have an additional access point. I'll show you a bit more about that in another slide. But then the interesting thing comes. So the device I chose or I bought allows me to send a data stream to any API endpoint that you host yourself. So if you spin up a small web server or Nginx endpoint or whatever, you can capture the data and then send it on to further components. So I wanted to have my data stream to my Home Assistant setup, so to register that data in my home automation system, but I wanted to have the data available in a dashboard as well, just for my personal consumption. So I use Nginx as kind of a reverse proxy that allows me to split that data stream or mirror that data stream. And I'll show you in a bit how I did it. Nginx comes with a built-in module which is called mirror, and any request that hits the endpoint is just duplicated to two other endpoints. So one of them is my Home Assistant setup, and the other one is Telegraph. More about that later, and then InfluxDB and Grafana, my dashboarding system. How it's actually running is everything is running on one physical box running some Ubuntu release, and then Home Assistant itself is running as a VM on VirtualBox on that physical Ubuntu server. So Nginx sends the data to my Home Assistant, and it sends it to Telegraph. Telegraph is like Logstash, but for APIs. So it has a ton of inputs, and then it has a filter section. You can modify the data, add fields, add metadata, change content, whatever. And then there's a ton of outputs. You can send it further along to other API endpoints, or you can send it to InfluxDB, which is a time series database. InfluxDB is quite new to me. I come from the Graphite era, which is like one of the first time series databases that were created many years ago. InfluxDB is the new shizzle. It's all JSON, and it's kind of cool, I think. And then InfluxDB talks nicely with Grafana, which is an open source dashboarding system, and I'll show you later on what data I'm capturing and how am I presenting it. Obviously, I wanted all this to be secure. I think that's an important thing when you're doing home setups, because it's easy to spin all this up and open it up to the internet, but then you're like with your pants down, and that's not something I really like. So I put a bit of effort in making all this secure. More on this later on because I forgot the exact order of my slides. What we see here is just my data being sent to one of those internet weather services. So this is the EcoWit thing we saw a couple slides back. It just records all my data, outdoor temperature, my indoor temperature from the base unit, and then I have one additional thermometer somewhere in my living room, so I capture data for outdoor, indoor, and then another place in my home. I intend of using this with my Home Assistant setup. So this is what comes out of the box. You don't need to do anything for this. You just connect your weather station unit to the internet, and you tell it to send its data to EcoWit, and there you have it, all that. But that was not good enough for me. I wanted to control that data and have it on my home system. So the diagram I showed you showed that I was not only sending data to EcoWit, but I'm also participating in this WOW project, so the weather observation website. I registered my little weather station with them. They gave me a unique ID. I pinpointed on the map where it's located, the elevation, the capabilities of my weather station, like it can record temperature, dew points, humidity, wind speeds, wind direction, rainfall, all that good stuff. So I registered, And now you can find this weather station on the WOW.be website. I'll show you in a bit. So here it is. And while researching this talk, I looked up my own weather station and I noticed something really odd. I live near Leuven, and when you look at this diagram or when you look at this screenshot, you can see that there's quite some WOW weather station registered in Belgium, but there are a lot of weather stations registered in Leuven, near where I live. And I was like, why? So I dug a little bit deeper, and so the mark here is where I live, or where my weather station is located, and then you have Leuven, and there's this extremely high concentration of weather stations, and I was like, but why is that the case? And it's just fun to know. Leuven has a project which is called Leuven.cool. It started a couple of years ago, and they wanted to know the effects of garden design on city city heat distribution, basically, because cities tend to be a lot hotter than the great outdoors or forests or whatever. And so they started a project like, can we design our gardens so that they have an effect on the global temperature inside a city? Can we use garden design to effectively lower temperatures inside a city? I didn't know it existed. I just discovered it because I registered my little weather station on this WOW website. So I think it's kind of cool. And the URL is actually leuven.cool, where you can read up on all this stuff. So this brings me to the security aspect of the whole thing. As you know, the internet is full of hackers. So I wanted to build a secure setup, and because I'm quite technical, I was able to pull it off. I think I built a really secure setup, just for the heck of it, because I know I'm sending my data out to the public internet. It's not very personal data, it's just my weather station, but I wanted to make it secure anyway. So what I did was, I'm using dynamic DNS for easy access to my home IP. That's not a really secure method, but it makes it easy to reach your the services you host at home. I'm sticking all my Internet of Things devices in a separate VLAN. They're just separated from my home NAS, and other services and stuff I run on my home network, all my iPads, phones, whatever. I restrict outbound bandwidth and ports from that VLAN. So should a device get hacked, then it can't use my internet connection to start mining bitcoins or start sending spam or whatever. I use client certificate authentication for all my inbound services. So each device I use to access the services I host at home need a certificate for authentication. Otherwise, you're not getting in. And then obviously I use Let's Encrypt certificates for all services I host on my home network. I think Let's Encrypt is like the best, most elegant service since sliced bread. It's so good, it's so easy to use, and it makes your services secure with A-grade HTTPS certificates or SSL certificates. I absolutely love it. So the disadvantages of all this, I think that a secure or a truly secure setup is not that easy. You really need to know what you're doing. You have to do everything yourself, because registering your device and having it connect to some random internet service is easy. If you want to do it yourself, then you need to put some time in there, and you need some IT and geekery skills to make it all work. Advantages: you have full control over your data, hardware and software. The cool thing is you can do everything yourself, and you need some geekery skills. I think that's really cool. So, about all the components I'm using. Like I said, I'm sending my data stream from my weather station through Telegraph into InfluxDB. This is InfluxDB. I'll show you in a bit in the browser what it can do. So this is where my data lives. It's like the most simple time series database. You have a timestamp, the name of your metric, and the value of that metric. Temperature, humidity, wind speed, wind direction, whatever. And so through some InfluxDB admin interface, you can query the data directly. I'll show you in a bit. Then the end result is a Grafana dashboard that's connected to my InfluxDB instance. And it allows me to build my own dashboard, show the metrics I'm interested in, and graph them out, which I think is really cool. So I have my outside temperature, my kitchen temperature, my living room temperature, same for the moist content, or the moist ratio, or humidity, I should say, and so on. And then the part that's not developed that much, unfortunately, is my home assistant setup. So, as I showed you in the beginning, Nginx is sending data to Telegraph and InfluxDB and Grafana, but it's also mirroring that data stream to Home Assistant, where I have installed a plugin that's compatible with the EcoWidth protocol that my weatherstation is sending out. And I'm capable of capturing all that data. Home Assistant will let me write some clever automation in the future that I haven't had time for, but the goal is to do some fun stuff with this. Like the easy thing would be, hey, if it's more than 20 degrees outside and the inside temperature is higher than the outside temperature, send an email so that I know I need to open up my windows. That would be something really silly to do. But like I said, I'm hoping to buy some open source thermostat system that can intelligently steer my central heating room by room, but I'm not there yet. It's just I'm gathering the data and I'll see where I end up. So the really technical part, if you're interested, we can skip this, but if anybody's interested. So this is my Nginx config with the mirror module. I wasn't aware that this existed, and I think it's really cool, because at first I wanted to use HAProxy, like my go-to reverse proxy for anything, but then I learned HAProxy cannot send data to backends on the same level. So it's either AB 50/50 hosting, but you cannot instruct HAProxy to send data to two web servers the same data stream, which took me a bit by surprise. So apparently Nginx can do this. So data's coming in on port whatever, 7080 in this case. That's the data stream that's coming from my weatherstation. And then I'm sending this to Telegraph for the InfluxDB and Grafana part. But I'm also telling this endpoint, like, hey, you need to mirror this and send it to Home Assistant. And then this location Home Assistant sends this data on to the IP address of the VM running Home Assistant. So it's a really cool, elegant setup, and it works just fine. Then the Telegraph config for this is quite easy. Like I said, it comes with a ton of inputs, and one of them is like an HTTP listener. So, okay, we're listening on port 708080 on an endpoint called Telegraph. We accept post and put, or get, or whatever you want. Max body size 1 megabyte for whatever reason. And what's my data source? The data is in the body. And then you need to do some URL encoding to pull the data stream apart. So that you can send it to your InfluxDB properly. So that's the input, and then output is like easy. I use InfluxDB. The output is running on my local host on some port. I need some authentication with an API key, and an organization, which is a logical bucket where everything is running. And then the name of the bucket itself, like the name of the database, is called Telegraph in my example. I think I can demo this to you in a bit. Yeah. I have a bunch of links of all this technology. I'll make sure to send this presentation to Jürgen or Wouter, and then maybe they can share it somewhere on wherever or maybe the mailing list, so you can go through all this. But it's not finished yet. I can demo some stuff. So like I said, the simplest example was the EcoWit stuff. This readable. Ah, no, it's too dark. Sorry. Is this? Can you see the graphs? No. But so this is like the freebie, send your data to the cloud stuff. Again, this is weather information. I don't think it's that critical, but there's other examples. Like, it might be silly, but a friend of mine is doing a major reconstruction of his house. He's forced to install an air ventilation system, and the air ventilation system is connected to the internet. And he was like, but why? I mean, I don't want it to be connected to the internet. Yeah, but why not? And he's like, well, I have ventilation systems, I have ventilators running in all of my toilets. I mean, this system records when some ventilation thing is running and for how long. I mean, there's no need to share that data. So that's a bit the point I'm trying to make. So I'll probably turn off this thing and just send it to the Weather Online, the WOW thing, which you can find here. So this is the UK version of this site where you register your weather station. You tell them what capabilities you run, and then there's the Belgian thing where you can see a map of Belgium and neighboring countries with all the weather stations. And mine is here running near Leuven somewhere. Yeah, Palmberg. And when you click it, you get my graphs and you get my data. I think it's nice, do some community data sharing stuff. But then I have all this data on my private home server as well, and that is running here. So this is my personal dashboard running on my home system, secured with a Let's Encrypt certificate, and you need a client certificate on your computer to access this data. I can show you, if I open up Firefox, for example, and I go here, it will ask me, like, okay, you need your private key for the cert you want to access. Really? And I was hoping it would come and ask me for the, hey, you need to use a certificate, but apparently it remembered it from last time, so sorry, bad example. And now I can't get rid of this thing, really. So without this certificate, you won't be able to gain access to this. So you can try and go to grafana.home.herbos.be. It should give you a big SSL warning like, hey, you're not offering me a client certificate, you're not getting in. So how is all this working? I told you we have this InfluxDB data, time series database. Yep. And we can browse the raw data that's coming in from the weather station. So it's in a Telegraph bucket, the HTTP listener from where we were, and then you have all the raw data, all the fields. Like, this is the raw data coming in from the weather station. Like, I'll pick one, an easy one, temp in Fahrenheit, not in centigrades, but we can just take a look. This is the temperature of the last 6 hours or the last 7 days, whatever. And Grafana, the dashboarding system, can consume this data. So if we go to a dashboard and we pick a metric, we can edit this metric. And is this readable? No. Oh. The thing is, oh, I broke it. So the thing is, you write this query from bucket, telegraph, time range, and so on, and then what fields do we need? And I need to do a small calculation to convert from Fahrenheit into centigrade, because that's what I'm used to. And then you get this beautiful, simple metric. This is real-time data. In my garden, it's 14.8 degrees. Yay. What else can I show you? Yeah, the Home Assistant thing. So Home Assistant is like, it has an endless array of plugins and stuff you can play with. I managed to register my my weather station here, like EcoWit thingy, and this just registers with what the Home Assistant calls sensors. This is a bit readable, yeah. So you have all these metrics, just like in Telegraph, available for you to play with, and you can write automations for them. But again, I haven't done this yet. So yeah, that was my talk. Any questions?
Yeah. So your weather station, how does it communicate with the interface?
Yeah, I'll show. Let me go to the diagram thingy.
Because it says here, I mean, on the product page it says Wi-Fi, but it's
So the communication between the hardware in the garden and the device in my kitchen or in my home, that this arrow is radio.
oh, that's right.
Yeah, yeah,
How far?
100 meters. Yeah,
It could be a wall.
yeah. My thing is like 50 to 60 meters in, like in an open field, and this hardware device is sitting near the window in my kitchen,
Okay.
and there's no connectivity issues whatsoever.
Because I'm wondering if I would buy one like that, I would put it on my, on my roof. But I don't know if it could be, if it could go through.
I'm not a radio specialist, unfortunately. I don't know.
Depends on what material you need to go to, and the theoretical maximum of 100, when you go to like a window, a well-isolated window will go down a couple of meters, will go down a couple of meters,
Yeah.
but it should still be able to make it through, depending on what you.
Yeah.
Is it 432 gigahertz or 868? No, the frequency.
But let's look it up.
Between gateway frequency, well, there's four different. So you can 433, 868, 915, and 920 megahertz, depending on your location. Apparently.
Yeah, so like 433 then? Yeah, here you have it. So glass, untreated, RF signal strength reduction. Yeah. Radio frequency will not pass through metal barriers. Okay.
And radio frequency can't really make it through metal, so that's why they're on there or something.
Yeah.
So putting it on the roof will probably not be the best.
No, but it also influences your the actual measurements you're making. Because if you place this weather station near a building, then the heat of the radiant heat of the building will influence the thermometer, and so they urge you to place this as far as possible from buildings on a high pole, so to get the most accurate or unbiased readings.
No, I didn't have a car.
Yeah. Okay. Yeah, that's something. Indeed. So yeah, that was me. Thanks for listening.